We've been given an f function and asked to sketch a graph of the f prime function. To do this, we want to use some properties. One property is that if we differentiate a polynomial to the power n, the derivative should have a polynomial power of n minus 1. If we have a horizontal tangent, we know that that represents the intercepts of the f prime graph, or where the horizontal tangent is, the derivative is equal to 0, so the f prime should hit the 0x intercept. The other part is if we have positive and negative slope on the graph, on the f prime graph, we should be above and below the x-axis. Okay, so positive slope means we have positive y-coordinates of the derivative, and negative slope means we have negative y-coordinates on the derivative. So starting with the horizontal tangents, what I've done here in A is I've located the horizontal tangent at -3. So I put a 0 at -3. I've got a horizontal tangent at +1. So we have a 0 at +1. It is a cubic function, so we should expect this function, the derivative function, to look quadratic. We have positive slope on the left side of that 0, so we know it's going to be positive y-coordinates like that. We have positive slopes on this side of the 0 coordinate, so it should be positive y-coordinates like that. And in between the zeros, we have negative, so we should be hitting negative y values, and the pattern is going to come back up, and the pattern is going to be essentially quadratic. If we want to try to calculate values of slope, okay, we can try to do that. It looks like here the slope is maybe at -2, maybe -2.5 at its max. We could do the same for B, looking at the horizontal tangents, where there's a horizontal tangent at -4, -1, +2, +4. We've marked the x-intercepts of the derivative function. Okay, so, and again, maybe I should make sure that's clear. This is an f prime graph here. We're going to draw in an f prime graph here. So then we can, again, it has 1, 2, 3, 4, 5 arms. So we should expect the derivative to look maybe a bit like a fourth degree polynomial. We can look for positive slope regions. Okay, we know it's positive slope in here, and we know it's positive slope in here. Okay, so in between here, we know that it's probably going to go up, stay in the positive, but has to come back down to 0. And in between here, it's got to stay in between the zeros. It's got to stay positive in between those zeros. We can mark out the negative parts of this graph. So on the left of that 0, in the middle here, and at the end, we know it's probably going to be negative and likely increasing slope, increasing negative. It looks like it's going to go negative, but it has to come back up to hit the 0. And again, it looks like it's continuing down to more negative, down like this. And we get a graph that looks like this. So it looks a little bit like a fourth degree polynomial. The original one looks a little bit like a fifth degree polynomial.